All right, number 7. Number 7 does qualify as another doozy. Got myself a calculator. I got myself a very large eraser for all the big mistakes I could make. And here we go. Let's dive in. So, a weight hanging from a spring bounces up and down infinitely with the same amplitude. There's your trigger, this is sine or cosine. So, when t is 5 seconds, see, right now I know I need to draw, and I don't want to make this too big, I don't want to make it too small, but I got to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We might need more than that, we might need less, but that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is seconds. So, when 5 seconds go by, the weight is 4 feet above the ground. So here's my height. 1, 2, 3, 4, I'll go 5, and then 6, and see what happens there. 1, 2, 3, 4, 5, 6. Try to be semi-accurate here. So, when 5 seconds has gone by, the weight is 4 feet above the ground. So we're going to go right about here. Alright, make that down a little bigger. I think it was a little low. When 7 seconds has gone by, the weight is 1 foot above the ground. So 7, right about there is 1. Again, my drawing is far from perfect, so don't call me out on that. But it's okay, I got this little drawing. Amplitude is your key to say, hey, this is probably sine of x or cosine of x. Well, how are we supposed to figure that out from this drawing? Well, we got to take a little look. So it doesn't really tell us in this information that this is the low point and this is the high point, but we have to make an assumption that that's true. So, with that being said, take a look. It goes from 5 seconds, so I'll just make this a coordinate point. 5, 4, and this is 7, 1. So what I'm going to do is I'm going to realize that from 5 seconds to 7 seconds, that's 2. That's half of the curve. So I'm going to come back to here from 5. 2 seconds would be here, and so I would kind of go like this. And then from 3 to 1 is another peak. So I'm going to go straight up here. And so you can see my curve building. And I'm going to stop right there. We'll talk about this little space in a little bit. But if we take a look at this, we can really get going. Actually, let's go ahead and get more detailed. So we can see, if we recall, that our sine function, the way I taught it, sine of x, our trigger is that it goes through the origin. If this thing starts coming down, I don't see that really happening. So I'm going to think about my cosine parent function that goes over, see that? It goes over the origin. I'm like, wait a minute, if that's the peak and it starts coming down, now we're going to get a little bit more precise with this in a second, because from here to here, we can figure out, now this drawing is going to be a little messy, but that whole distance, down 1, up 4, is 3. So that's 3 units. But remember, this x-axis is what cuts the cosine curve in half horizontally. So we're going to cut this in half based on this being 3. I'm going to go 1.5 down from 4, or 1.5 up from 1, which puts me at 2.5. And that's kind of like my new... That's where the x-axis, and again, my drawing's not perfect, but think of that as the x-axis. So now we establish the fact that we believe this is cosine, because if the cosine curve, so this comes back down to here in 1 second. So from here down to the line to 2.5 is kind of being like that. Again, my drawing's far from perfect. But I can now see that cosine's been moved to the right 1 unit. So it's like moving that peak over to the right 1. So let's get some pieces going. We know y equals a cosine b x plus or minus c. We'll talk about that in a minute. And then plus d. Now, if this is all three, we know that this has to be 1.5, or this has to be 1.5, which is telling us A is 1.5. The other thing we can tell is that, remember, our original x-axis is what cuts cosine in half, and that's this, and that was elevated up. That's up 2.5 units. So this right here is got to be 2.5, and it's going to be a plus. Now what about this plus or minus c? Well, cosine was moved to the right one, so we're going to go x minus 1 in there, because that's my c value, and it's got to be minus to go right. So really, what's this b thing all about? Well, remember, the formula, period, equals 2 pi all over b. Yes, the absolute value of b, but we're going to leave that alone. What's the period? The period is how long it takes to go through one cycle. So from 3 to 7, that'd be 4 seconds. So I'm going to put a 4 in there, and I'm going to go 2 pi all over b. Now what I'm going to do is multiply both sides by b, cancel, multiply that by b, so I get 4b equals 2 pi, divide by 4, and I get pi over 2. That's my b. So that's what this is. I know it's like, whoa, how is this all fitting together? Well, it just does. So every picture tells a story, and this is telling us a story. So y equals 1.5 cosine, and I forgot one thing. Write the equation to represent the situation. So obviously that's what I'm trying to do. Whoops, I didn't show it on the screen. Write an equation to represent the situation. So here's the drawing. Can't get away from drawing the drawing on this. And then pi over 2 x minus 1 plus 2.5. So there's my answer for part A. All right, I'm going to pause this a second. All right, part B. What was the height? And remember, on our graph, our x-axis is time, and our y-axis is our height. So if we really analyze that, they're saying find y when t, or x, equals 12.5 seconds. So it's really just plug 12.5 in there and crunch a bunch of. So let's do that. Y equals 1.5 cosine. There's a little trick in here. Pi over 2, 12.5 seconds minus 1 plus 2.5. So really we just got to calculator this. Now, speaking of calculators, I'm not worried about this. I'm going to put a light line through it, and I'm not worried about this. I'm worried about all of this. This is telling me my calculator better be in radians, because that's the form this is in. So if you made this mistake and did all your math right, that'd be a shame. So let's go and check our mode. Notice I'm in degree mode. That would have been tragic. So we're in radian mode. Clear it. Now our calculator is going to handle this. Now what I'm going to do is figure out what this is. I know this is 11.5 PEMDAS times pi over 2. So I'm going to go pi divided by 2 times 11.5. And so I get cosine of 18.06. I'm going to be really precise. So cosine of 18.06. And I get, this gives me 0.704, but I got to multiply that by 1.5. Remember, we can't forget about that. 1.5. And so we really get, this whole thing is 1.056 plus 2.5. 2.5. So I'm going to go plus 2.5. And I get 3.56, so I'm going to go squiggly lines really close to 3.56. Now, if we want to have a little fun, which math nerds do, after 12.5 seconds, it's supposed to be 3.5 feet high-ish. If we take a look at our very non-perfect drawing, 10, 11, 12, 13. So here's 12, here's 13. We're figuring out what the height is if we went up from here. So if we kept going like this, from 3 to 7 is 4. From here to 11, it would go back up here, and then back down to 11, and then 2 seconds later, it'd try to get up to the peak, which would be right here, and this is where my drawing's going to get a little wonky. But after 12.5 seconds, we're supposed to be able to go up and figure out what the height is. And our answer says 3.56. If we went straight across, we'd be, and again, my drawing's not perfect, but you can see, yeah, my drawing's way off, but you get the idea. So it looks decent. Yeah, I had to curve that down, but maybe it goes, maybe this is wider, maybe this is over here a little bit more, and then it'd be up a little higher. But anyways, we feel good about our answer, 3.56. Now for a little tricky one. So let me pause this and get ready for this one. Okay, grand finale, number 7. When is the second time that the spring has a height of 2 feet 7 inches? So I converted 2 feet 7 inches right here to 2 7/12, because there's 12 inches in a foot, so that's 7/12, which reduces to 2.583. So we're going to do a real sneaky little thing here. 2.5 feet. I know it's a little more than that, but we're going to use our beautiful drawing just to make sense of all of this. Remember, our midline right here, cutting it in half, is 2.5. So it starts at 2.5. So we're just going to call it 2.5. So at 0 seconds is where it starts. Now it says, when's the second time? Well, remember, it takes, if we go, I mean, you can pick any section here, from here to here, or from here to here is probably good. It takes 4 seconds to complete a cycle. So if you notice, this goes from here to here and from here to here. So I'll just highlight this portion. This is 1 cycle, and that's 4 seconds. So notice here it's at 2.5, here it's at 2.5, and here it's at height 2.5. So at 0 seconds, 2 seconds, and 4 seconds. So the first time is at 0 seconds. The second time is at 2 seconds. Now, if they're not counting this as the first time, like that's your starting point, maybe they're going to say, well, the second time is 4. But regardless of what your interpretation is of the question, I hope that explanation makes sense. The question's a little bit ambiguous, so we'll leave it at that. All right. Well, we're finally done with all that, all the sinusoids. So let's try to squeeze a couple more problems like this in. So it says, use the angle sum or difference formula to find the exact value. So we're going to talk about what that means really soon. So the clue is we have to make that cosine of u plus v or cosine of u minus v. If we're going to use this or this, we need angles where their reference angles are 30, 60, or 45. Now notice 60 and 45 just coinkadinkly add up to 105. So I'm not going to use subtraction. I'm going to use addition. So I'm going to go 60 plus 45. Here's my u, here's my v. All right. Now, give me a second. I'm going to find this formula. Okay, so I discovered the formula. Went with 60 and 45 because that adds up to 105. Here's my u, here's my v. We just got to fill stuff in. Now, what does this mean? I'm going to show you. So we're going to go cosine of 60, cosine of 45, minus sine of 60, sine of 45. Now, every now and then a student asks, can you switch these? And the answer is yes. So this could be 45 and 60. The formula will take care of it for you. All right. So I'm going to grab this piece of paper because I'm running out of workspace. So as you can see, we need a 60-degree angle and a 45-degree angle. So we're going to go like this, 30, 60, 90, cosine of 60 degrees. So we look at that as our reference angle. Here's our square root of 3. This is 1, that's 2. So cosine of 60 degrees would be adjacent over hypotenuse. That's 1/2. Cosine of 45, let's just draw 45, 45, 90, 1 square root of 2. Here's my 45-degree angle. So cosine of 45 would be adjacent over hypotenuse, or 1 over the square root of 2. Follow the formula. Minus, now we got to find sine of 60. So that'd be square root of 3 over 2. Then sine of 45 would be opposite over hypotenuse. Now, exact value means we don't just shove this in a calculator to get a decimal. We don't just shove that in a calculator and get a decimal. We got to draw our triangles. If this is a multiple, anyways, we'll just keep going. So 1 over 2 square root of 2 minus the square root of 3 over 2 square root of 2. We're not worried about getting the radicals out of the denominator yet, because we got common denominators. So that'd be 1 minus the square root of 3 over 2 square root of 2. Now, we don't care about that 2. We're just attacking the square root of 2, so we're going to multiply this by the square root of 2, but then we got to multiply the whole top by the square root of 2. So distribute, distribute, so we get the square root of 2 minus the square root of 6. Square root of 2 times the square root of 2 is 2, times 2 is 4. And then there's your answer for part A, kind of a long problem. I'm going to end that video right there. Actually, let's squeeze this one in. So sine of 375 degrees. Again, bigger number. It's going to be more challenging to find stuff that works, especially with this rule. Your reference angles need to be 30, 60, 45. So, and you can only pick 2, not 3, 2. So what's jumping out at me is, and I'm going to take a stab at it, is I'm going to go ahead and take 45 away from here and see what that does. So I get 330 plus 45. This adds up to 375. Now if I spin my spinner 330, I'm going to have a 30-degree reference angle, which means this is a good choice. In other words, you can't take 370 like 4 degrees and add 1. Even though this plus this adds up to 375, those do not have reference angles of 30, 60, or 45. So there's your strategy. So now that we know that U is 330, V is 45, we can take this formula that I found. So sine of 330, hopefully I can squeeze this in, cosine of 45 plus cosine of 330, sine of 45. All right, sine of 330. I'm going to go ahead and get this paper right here. Let's draw this picture a little bigger. We spin our spinner 330, which leaves us with a nice little neat 30-degree angle. Come back here to the x-axis. There's my 1, but it's got to be negative. This is my 60, so that's square root of 3, and my hypotenuse is 2. So what is sine of 330? I'll do my work over here. That'd be negative 1 over 2. What is cosine of 45? Well, we already figured it out. We already figured it out right here, and that is 1 over the square root of 2. So we're going to steal that, 1 over the square root of 2. And then cosine of 330 would be adjacent over hypotenuse, but there's a plus in there. So adjacent over hypotenuse. And then sine of 45 is the same thing as cosine of 45. We just did that one on the other page. Multiply this together, so we get negative 1 over 2 square root of 2. Multiply this together, square root of 3 over 2 square root of 2. Again, we got common denominator, so it's negative 1 plus the square root of 3 over 2 square root of 2. Now you notice these answers are going to be similar. They just are. But we're going to get the square root of 2 out of there. So we got to do it to the top. This is a 2 times 2 is 4, so my denominator is 4. Distribute, distribute, so we get negative square root of 2 plus the square root of 6. Now a lot of times they'll write it like this. They'll just put the negative 1 second, so don't panic if you see different variations of the same answer. That finishes this video, you guys. The rest of this exam review will move a lot faster now that we're away from those dang sinusoids. So, good job working hard. Keep it up. See me if you have any questions. If you like the video, like and subscribe. You gotta go famous.